Hello students, welcome back once again. Today we shall discuss about liquid state of matter. Intermolecular forces are stronger in liquid state than in gaseous state. Since liquid molecules are close, that there is very less space between them as compared to gaseous molecules. So what do we understand from here is, in case of liquids, intermolecular forces of attraction is stronger as compared to gases, so that molecules are closer to each other and they behave as liquids. First of all, let us see what is vapor pressure. At any temperature, some molecules in a liquid have enough energy to escape. As the temperature rises, the fraction of molecules that have enough energy to escape increases. The liquid molecules evaporate and vapor molecules condense at the same rate. Thus, the liquid and vapor reach a state of dynamic equilibrium. As you see in the figure, some molecules of liquid are actually converting it into gaseous molecules, and the number of gaseous molecules, once it increases, it starts condensing and coming back into the liquid form again. So this process is actually continuous, and they reach a state we call it as equilibrium state, where the process of evaporation as well as condensation takes place simultaneously.
If you take water in a container and you allow it to start evaporating, the space above the surface of the water will start getting water molecules. That means it's a gas now, and gases impart pressures. So as that builds up, what's going to happen is these particles floating above the water can go back into the water unless they're whisked away. So if you put a lid on the container, all the particles are trapped, so the water starts going back into the water phase, or I should say the water vapor goes back in. As this happens, you finally reach a state at which the exiting evaporation rate equals the entering condensation rate, and you reach what we call equilibrium. So when those two rates equal, you establish a constant pressure inside your container, and that pressure is called the vapor pressure of that liquid. In the case of water, you would say it's the vapor pressure of water. It's an example of what we call dynamic equilibrium, meaning when you look at the thing, you can't tell anything's happening, but in actuality, there are billions and billions of molecules leaving the surface of the water, and there's also billions and billions re-entering, and they are exactly the same rate, so there's no net change, but you have established what we call a vapor pressure.
The boiling point of a liquid is the temperature at which its vapor pressure equals the atmospheric pressure. So the boiling point of a liquid can be said as the temperature at which vapor pressure equals the atmospheric pressure. The normal boiling point is the temperature at which its vapor pressure is 760 torr. The standard boiling point is the temperature at which the pressure is 1 bar. 1 bar pressure is slightly less than 1 atmospheric pressure. The temperature at which the density of liquid and vapors become same is called critical temperature. What is critical temperature? The temperature at which the density of liquid and vapors becomes same is called critical temperature. Next, we shall see the relationship between vapor pressure and temperature curve of common liquids. This graph shows the temperature at which these gases boil, especially diethyl ether, ethyl alcohol, and water. Now let's look at another important term, that is surface tension.
Surface tension, in which we will look at how intermolecular forces affect the surface of a liquid. So what is going on at the surface of a liquid? Let's take a look by shrinking to the nanoscale So here we are looking at the individual molecules in a liquid, and let's say that each blue circle represents a molecule of water. Due to kinetic energy, the particles that make up a liquid are in constant random motion, and so they will have a random arrangement. You might expect the particles at the surface at the micro level to form a random surface as shown here. But what we should find out is how do intermolecular attractions influence the surface? First, let's look at intermolecular forces under the surface, where attractions of individual molecules pull on each other in all directions. At the surface, pull on the molecules is lateral and downward. There is negligible attractions above the molecules, and so the net force on surface molecules is downward. The result of this downward force is that surface particles are pulled down until counterbalanced by the compression resistance of the liquid. Surface molecules are compressed more tightly together at the surface, forming a sort of skin on the surface with less distance between them compared to the molecules below them. Surface molecules also form a much smoother surface than one would expect from randomly moving molecules. What do you think surface tension would do to a liquid not confined in a container? In this model of a small water droplet, what is the net direction of the force on the surface molecules? That's right, it is toward the center. And so a free-falling drop of liquid takes on a spherical shape. Here we see water dripping from a faucet. If this does not look familiar to you, turn on your faucet at home with very little pressure and see what happens. Or do an internet search for the behavior of water in zero gravity to get a great view of surface tension. Water in particular has a very high surface tension. Do you know the reason for this? What creates the attraction between water molecules? In looking at an individual water molecule, we can see the particularly strong attraction between the oxygen and hydrogen due to their opposite charges. Hydrogen has a strong partial positive charge and oxygen a strong partial negative charge. This strong attraction occurs between any water molecules close by. The strong partial charges result in a strong attraction between water molecules called hydrogen bonding.
The phenomenon caused due to the characteristic property of liquid is called surface tension. The surface of a liquid behaves as a membrane or barrier. Surface tension results from the net inward force experienced by the molecules on the surface of a liquid. Surface tension is defined as the force acting per unit length perpendicular to the line drawn on the surface of liquid. What is surface tension? Surface tension is defined as the force acting per unit length perpendicular to the line drawn on the surface of liquid. SI unit of surface tension is Newton per meter. When attractive forces are large, surface tension is also large. Increase in temperature increases the kinetic energy of molecules and effectiveness of intermolecular attraction decreases. So surface tension decreases as the temperature is raised. Liquid tends to rise or fall in capillary because of surface tension. It is surface tension which gives a stretching property of surface of liquid. On flat surface, droplets are slightly flattened by the effect of gravity. But in the gravity-free environments, drops are perfectly spherical in nature. So the spherical nature of droplets as well as the capillary action are due to surface tension. Fire polishing of glass. On heating, the glass melts and the surface of liquid tends to take the round shape at the edges, which makes the edges smooth. When the surface area is minimum, then the energy state of the liquid is low. Spherical shape satisfies this condition. Hence, mercury drops are spherical in shape. So, the importance of surface tension is because of surface tension, substances would like to remain in the spherical form in order to minimize the surface area, and because of that, then energy state of liquid will be low. Finally, we have viscosity.
We know that in solids, there is a strong attractive force between molecules. As we heat the solid, this attractive force becomes less effective because of increased vibration of molecules because of heat energy. As the attractive force becomes less and less effective, movement of particles, relative to each other, starts. Addition of more and more energy results in more and more movements, and solid starts converting to liquid. For a given temperature, different liquids showcase different magnitude of relative movement between molecules. This relative movement is measured in terms of physical quantity called viscosity. A liquid is more viscous when there is strong attraction force and relative movement of particles is less. And a liquid is less viscous when there is less attraction force between molecules and there is an easy movement of particles relative to each other. If we compare engine oil and water, engine oil is more viscous force compared to water. Now, imagine a boat is moving on water. With boat, water molecules on top layer are also moving. As we move deeper and deeper, movement of particles reduces. Since there is an attractive force between molecules, deeper molecules try to prevent surface particles to move with boat. And to overcome this force, boat need to apply more force. Force which prevents relative movement of particles or layers of liquid is called viscous force. More the viscosity, more will be the viscous force and more efforts one needs to put to move layers of liquid on top of each other. If we drive boats on oil and water, boat on oil will consume more fuel because oil is more viscous compared to water and thus more energy will be required to overcome this force.
A force is required to maintain the flow of layers. This force is proportional to the area of contact of layers and velocity gradient. F is proportional to A, that is area of contact, and F is also proportional to velocity gradient du by dz. On combining these both, we get F is proportional to A into du by dz. If you change the proportionality, we put a constant that is eta. F is equal to eta into A into du by dz. Here eta is coefficient of viscosity and SI unit is 1 Newton second per square meter. The stronger the intermolecular forces, higher the viscosity. So children, today we have discussed about liquid state and surface tension as well as viscosity. Go through the topics clearly and prepare well for the chapter test. Thank you and have a nice day.